In order to discover distant galaxies, astronomers need to scan the night sky and obtain really deep images, well beyond what our eyes or typical telescopes can see. One of the best studied large areas in the sky is cosmos, short for the Cosmic Evolution Survey. This area of the sky, located in the constellation of Sextans, is visible during the winter and spring in the northern hemisphere. It is the largest that the Hubble Space Telescope ever surveyed, covering an equivalent of 8 full moons.
What makes Cosmos even more exciting is the fact that pretty much every single professional telescope in the world has observed this field across a wide range of wavelengths. This allows us to obtain colour images, but also to take X-rays of galaxies or listen to them in the radio, even if they are incredibly far away. Surveys like Cosmos are really important for astronomy and astrophysics and have led to numerous discoveries already. Looking at distant galaxies in the universe allows us to travel back in time and see how the universe was billions of years ago, when galaxies were starting to form. Each discovery broadens the extent of human knowledge and is also just very exciting.
The famous galaxy that we have named Cosmos Redshift 7, or CR7, was discovered in the cosmos field by us and is the brightest galaxy in the early universe. We can see CR7 as it was almost 13 billion years ago. We have also discovered other incredibly bright galaxies in the cosmos field, like the one we named Masosa, and we have recently discovered another 4,000 distant galaxies in the same field. This was only possible because the cosmos field covers a total area of about 2 square degrees, or 8 full moons as we see it on the sky. We actually expect that the field contains more than 2 million galaxies ready to be discovered and studied. But how do we find galaxies? How do we know they really are incredibly distant? Can we go back in time to very specific ages of the universe? In order to do that, we need very well thought out time-traveling experiments, which usually require large telescopes and highly sophisticated instruments, so we can use them as time machines.
At Lancaster, we explore numerous narrowband filters which only allow light to go through with a specific energy or colour. We use these filters to time travel back in time to very specific epochs of the universe, all the way up to more than 13 billion years ago. The filters allow us to see galaxies lighting up depending on how far away or how redshifted they are. By using the 8.2 meter Subaru telescope in Hawaii and the 2.5 meter Isaac Newton telescope in the Canary Islands, we have surveyed the full cosmos field with 16 different filters, some built by us specifically to search for distant galaxies glowing in hydrogen. We use multiple, large, deep images to slice the cosmos field into 16 different slices and identify galaxies for which the light has been stretched or redshifted by significant amounts from 2 to 6 times. This allows us to go back in time from 11 to 13 billion years into the past, and we have found 4,000 new super distant galaxies.
These are part of a sample of galaxies that we call SC4K, as we slice the cosmos field into different redshift slices and find 4,000 distant galaxies. Want to know how we do it? All 4,000 galaxies in SC4K have been discovered due to their glow in hydrogen. The universe is full of hydrogen, and if clouds of hydrogen are sufficiently close to very big and hot stars, hydrogen atoms get destroyed. When they come back together, they emit a unique glow, including light in the ultraviolet, 1260 angstrom. This energetic light comes in the form of photons with a very specific energy, and we call them Lyman alpha photons. As these Lyman alpha photons travel through the large expanding universe, they get redshifted and they reach Earth with much redder wavelengths.
Our filters are able to catch these photons after they've travelled for billions of years, and depending on which of the filter detects them, we can know how far they've travelled. These photons contain information about the very distant galaxies. They can tell us what was happening in the galaxy when the photon was emitted and began travelling towards us.
We can even use X-ray data obtained with the Chandra Space Telescope to identify which of the distant galaxies host actively growing supermassive black holes.
Now that you know how we slice the universe in cosmic time with SC4K, are you ready to do it yourself with some real data? What will you discover about super distant galaxies and their supermassive black holes?